He at work because he doesn't talk to me anymore. All right, so today we're again talking about data collection and sampling techniques. So in Objective 5, we're going to identify the 4 basic sampling techniques. So data can be used to describe situations or events. Data can be collected numerous ways. The most common is surveys, such as a telephone survey, mailed questionnaires, personal interviews, observations, or just reviewing records. Researchers use samples, and we talked about this. If we can't take a poll of the entire population, we can take a sample of the population. To collect data about variables from a large population. However, samples cannot be collected haphazardly because the data collected might be what we like to call biased. Biased is a hard thing to avoid. To obtain unbiased samples, that is, samples that give each subject in the population an equally likely chance of being selected. So we talked about this. If you really want good data, everybody in your population has to have the same opportunity to be chosen. Now, if it randomly got chosen where 4 of y'all out of the entire school got chosen for something, that's just by chance. But everybody in the school or population had to have the same opportunity. That's how you can get unbiased. But we have samples because that's not easy. I can randomly select you, but you could say, I don't want to answer your questions. You could say, I might do letters and you might not fill it out. I could do a phone call and you could ignore me as spam. There's so many factors that I randomly chose you, but you didn't want to answer my survey. So now I had to go towards somebody else, and now the data is being a little unbiased, or now becoming biased. Right, so that's kind of the things that happen. So it's really hard to get that unbiased situation there. All right, statisticians use 4 basic methods of sampling. They are random, which is the best sampling. This is everyone has an equal opportunity. Systematically, we can basically put y'all into groups and then pull things out of those groups. Stratified, I can put y'all in rows and then just select an entire row, right? I can be like, I can randomly go, all right, I'm going to poll everyone here, and I'm going to go 1, 2, 3, and I pick 2, so I'm going to pick everybody in this row. That's kind of stratified. I'm putting y'all into categories and then randomly selecting those categories. And then the last one, which we cannot see, is sampling. Maybe. Cluster sampling, right? Which again, if I wanted to take a poll of this entire school, I'll be like, hey, I'm just going to cluster y'all and get y'all's opinion. And that must be the same as everybody else in the school. That's cluster sampling, also known as convenience sampling. You are convenient to my poll, so I'm going to poll y'all. And you get a lot of those in your political statistics there. That's convenient because they pulled a blue state or a red state and said, hey, this is what the numbers are saying. But let's break this completely down so we fully understand. We'll start off with random samples. So again, this is random samples. I'm really digging this color. All right, so random samples are selected by using chance methods or random numbers. Best thing to do is if there's 500 kids, don't look at them as like a person, just give them a number. So you randomly assign these numbers and then you go, and I want, and you'll do some type of generator. So you don't even come up with yourself. You'll be like, all right, I want 18, 22, 117, whatever these other random numbers, and then those people that are attached to the number then become my poll. And that's a unbiased thing because all of y'all had an equal opportunity to be selected because each number would have had an equal opportunity to be selected. We will have an opportunity today to play around with a calculator, and I'll show you some cool things that you could do in a calculator to randomly select things. All right, so one method is to associate number cards with each item in the population, mixing the cards and selecting all the cards needed. Another is to select numbers such as for lotteries by mixing balls marked with possible numbers with forced air and selecting the one that rises to the top. So that's what we do when you do a lottery ticket. Each number has the same probability of rolling up. And so everybody that buys a ticket has the same probability of winning or not, depending on what numbers they chose, because every number had the same probability. Completely unbiased. One more time. Now they're cheating and it's now unbiased. So now there is a skewed situation. Yeah, not supposed to do that. All right, here we go. So let's do an example real quick so we fully understand. Select a coin I don't have, but I can do Siri real quick. Hey, Siri, flip a coin. Hey, Siri. Hey, Siri. I like it. I'm kidding. It's got to be a random thing. No one's got a coin on them in their purse or something? Can't flip a bill. Yeah, but it's not the same thing. It doesn't have the same weight. Hold on, let's see. Flip a coin. Okay. I just flipped a coin and it was heads. Okay, so we got a heads. We're going to do it 5 times. Oh. So I got a heads. I'm going to flip a coin again. I got a heads. All right. Again. I got a heads. It could be. It's online. But it's not me rigging it. Heads. Heads. All right, so that was 5. All right, so select a coin you have. Mine was a Google little thing. Flip it 5 times, recording heads or tails for each. How many heads? Sorry, I was looking at 5, right? How many heads did 5 of your classmates toss? Select a coin you have. How many heads did 5 of you? Were you supposed to do this too? Y'all do it. Pull out y'all's phones and do the thing. Calculate 5 of them. I just Googled flip a coin and it popped up with something I can just keep on hitting, flip it again, flip it again, flip it again. And then tally it up. So record it 5 times. Go 5 times with it. Did you? I'm going to do mine and see if it ever does. Did y'all see the same thing? Like the one with like a girl and then, okay. Right, how many you got right now? That could be your category right here. And then together we'll do it. Yeah. So the next one is how many heads did 5 of your classmates talk? I can count as one of your classmates. So go ahead and poll 4 other people or 5. You don't have to choose me. Charlie, how many did you get? 3? I need one more. Olivia, how many did you get? 1. Okay. Oh, I didn't catch you. Sorry. All right. So, how many heads did your classmates toss? 1, 3, 5, 3, 1. Were they the same? Yes or no? No. Not all of them, at least. So, flipping coins is an example of a random experiment. I flipped it, got 5 times. Y'all flipped it and got 1, 3, 5, 3, and 1. So, again, that's just a random thing. Each side of the coin had the same probability of being selected. All right. So, that's a non-biased experiment. Any questions on random? All right, those are the best. All right, so populations are often too large for this previous method. So random numbers are generated using a computer or calculator. So suppose the company of which you work has 9,863 employees, and your department needs a sample of employees for a study. You have determined that the sample must have at least 842 subjects. A sample of 842 numbers between 1 and 9,863 without repetition could be generated using a computer's random number generator and the employees associated with the selected number in the sample. So this is what I was talking about earlier. If I wanted to poll everybody in the school, I would randomly assign everybody a number, and then I would then randomly have a generator pull those numbers out so that everybody can have an equal opportunity, because I'm not going to poll 9,863 people or poll 500 students. So that just seems a little impossible. So go ahead and grab an Inspire. This is 84's information, but I'll show you how you can use it with the All right, so if you just go to regular calc, which is short for calculator, that app is right here. What we're going to do is you can actually just type in RAND for random, INT. Notice that I went from italics to nice print looking. So again, that's RAND, capital INT. Shift. When you type it completely correct, it will untalicize itself. Yes, that's how you know you did it right. Everyone got it? So what we're about to do is I want to randomly generate 10 numbers out of 85 in my population, right? So if I have 85 in my population, I want to randomly select 10. I can't do it because I might be biased to a certain number, which is going to skew my data, right? So if we have computer do it, we'll say, I want you to select 1 out of 85, and I want you to do it 10 times. So you do whatever your list of numbers is, so 1 to 85, and how many you want to pull, and then you hit enter, and it randomly selects 10 of them for you. Oh, we got the same numbers? No joke. Really? The computers are skewed. Anyways, we should have all got different ones. But in a situation that you're doing it, you're probably not going to pay attention to someone else doing it anyways. But I can now say that these assign the numbers. These are the numbers I would randomly choose. So the 81st person, the 78th, the 13th, all the way down, and then I can pull their data. So this is an example of how you can randomly select people for a random sample. It does. If you don't like it, you can do it again. That's too crazy. Yeah, they got a system here. All right. Well, that's interesting information to know. So use the right arrow, blah, 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 historically. Okay. So we did that. Chose it for 85 answers. So if you go to page 11, it might be hard to then skew all of those people. So what we can do is this is, let's see if it keeps on going. Let's see what it said. So use a random number table, select 10. We did that from a population of 85. All right, so let's say, let me jump back to our notes. So that's a one way, and that's probably the way I would do it. But there are other random things. Let's say you have them on a nice list. Let's say we can see that all. Let's zoom out a little bit. It's 11 the last number. It is. Okay. So let's say I didn't want to use a calculator. Maybe I don't have computers. So I randomly wrote all those numbers down in a random order, or maybe I assigned people the number and then had them check in, and that's how they checked in. Don't know how the data got there. But what we can do for randomness on your page right now, is everyone on this page? Is everyone on this page? I want y'all to close your eyes. All right. I want you to pick up your index finger, either right or left. It doesn't matter which one. And I want you to randomly place it on your paper. All right. Now open up your eyes. Circle that first number that you are touching, the closest number that you are touching. If you didn't hit it, close your eyes again and try again. All right. Whatever you landed on, circle that number. If I want to randomly do it, okay, cool. We'll say 93. Okay. I did not. Which one did I hit? I don't even remember now. I was? Where was I? I was like, okay, 34. I don't care. I chose 34. All right, so 34 is my first number. If I wanted to randomly now select 34 or 10 people, I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the people I'm randomly selecting. Huh? This is true. So if you're close to the bottom, you would go back up to the top and keep going down until you got to 10. You randomly selected a starting spot, so every spot had an equal opportunity to be selected, and then the same rules were applied. Wherever I landed, I went 10 down. If I went all the way to the bottom, I went to the next list. They all still have the same random chances. So start with that first one. Yes, but they had the same probability as the rest of the numbers because of where you started. Right? So that's another way if you didn't want to use a calculator. But you would have to then randomly, and this is like what we call a double random. They could have randomly written all these numbers with the calculator and then randomly chose a number to start with. I wouldn't list this as 1 through 85 because wherever you're at won't have the same equal opportunity of being in that spot. It's like playing squares. You ever play squares in a football game? Like basically what you do is you buy like 100 square. There's 100 squares to buy, a 10 by 10 for all the different numbers you can have. And then what you do is you do it without numbers. So I would buy, this spot over here on the left and this spot over here on the right. And then someone then randomly selects numbers to go 0 through 9 on top and randomly 0 through 9 on the right. And then basically at the end of each quarter, whatever the final score was for that quarter, let's say it was 14-7, I would go to 4 and 7, and that person would win whatever the pot is for the first quarter. But every square originally had an equal opportunity of winning, and then we re-randomized it. So it's a random here and then a random here. So double random. Yep. Squares is what we call it. All right, so there's that. So again, number items here. This works for a population of 85. We did all these things. All right, so let's go into this. And let's talk about systematic samples. So systematic samples are random samples attained by numbering each subject of the population and choosing every kth subject. The first subject is selected by a random choosing a number between 1 and k. Then every kth subject in the list is also selected. So basically what we do is you would literally go, all right, there's 500 people, choose a number randomly. 8, perfect. Now you're going to choose the 8th person so after you numbered everybody, you're going to choose the 8th person every time. So you choose 8, then 16, then 24, then 32, then 56 or 48. Sorry, no, 40, 48, and then 56. So that is what we call systematic. And so what would happen is, depending on how many you want, you would then have to exceed that. But that's exactly what systematic means. You would have 85 people. If you chose 8, again, you would go 8, 16, 24, and you would choose those place values. That is systematic. You'll randomly start it with 1. You can even do a number generator if you want it, and then you win every kth turn. Okay. So that's basically what it's stating here. So systematic sampling has the advantage of selecting subjects throughout an ordered population. This sample method is fast and convenient if the population can be easily numbered. It's not always so easily. So suppose there's a list of 350 subjects and a sample of 35 is needed. So 35 divided by 350 divided by 35 is 10. So they would then break it down by 10. So if you didn't want it to be so random and you specifically needed amount of numbers, you just divide by however many you want, and then you go 10, 20, 30, 40, and you select all of those places. So everybody had a random number to be chosen, and then systematically, I just went 10, 20, 30 without having to do a random number generator to find out all those. No, this would be a systematic because it wasn't. Mm-hmm. Oh, good. Mm-hmm. Mm-hmm. Okay, so in that situation, yes, but in this case, that's not what's happening. In this case, it's systematic because you're choosing place value. So like randomly, everyone did get a random number, but to make it easy, I wanted 35, so I'm going to do 10, 20, 30, 40 for those random numbers. So it became systematic because those numbers, so everyone randomly got a number, but then the numbers you chose didn't become random. So that becomes systematic. And it could be technically a little biased, who knows? But we try to keep it as non-biased as we can. So here it says, use your calculator to randomly select a number between 1 and 10. So do that, doing what we just did. Is it? I want to see. I want to know. So remember, you do RAND, capital INT, parentheses, and then 1, 10, 1, because you just want one number. Well, what did I get? I got 10. I wonder if it's because we did it twice. This is so not random. There's like algorithm going on here. So me and Rivers did it twice to see what our numbers were. So we got 10. Y'all didn't do that. Y'all just did it once. So y'all all got 8. Oh, okay. That's different. Very, very non-random there. All right. So use your calculator, randomly select a number. Let's say I'll go with the census and we'll go with 8. This is the first subject selected. The sample includes the first blank and each one of the following by adding 10 to each of the following. So what you could do, the sample includes the first. Includes in each one following by adding 10 to each. So the sample includes the first 18th is what I want to say. And each of the following by adding 10 to each of the following. So that's what I'm going to go with. So the first one, which was 8, and then 18, and then it would go 28, and then 38, and then 48, adding 10 to each of the following. So then if we list it, our systematic sample, how many are we trying to get? 10 subjects. So then we would go 8, 18, 28, 38, 48, 58, 68, 78. That disappeared. I don't know why. Yeah, sure. Yes, well, I'll eventually get there. 88, 98, and then 108. So those are my random 10 people in my sample of 350. But it's more of a systematic. You randomly start it somewhere, but then it became systematic after that. They no longer had an equal opportunity. Any questions on systematic? Right. It then does say compare your sample with subjects chosen by your classmates, but our calculator all gave us the same answer. So if you did go by 10 or the 1, then of course you will have some different data. All right, the next one is stratified sampling. So that's what it is here, stratified sampling. Oh, it's right there. So stratified samples are obtained by dividing the population into groups according to a characteristic important to the study. So a random sample is taken from each group. So basically, if I was doing hair colors or something like that, I could split everybody in the population with black hair, brown hair, blonde hair, and so on and so on. And then from that, then pull random kids in each one of those groups. So stratified sample is basically putting everybody in groups and then randomly selecting people out of those groups. All right, that's stratified. So, and we could also do it by age too in this high school. I could randomly say, all right, my 12-year-olds all the way to my 18-year-olds. And then from there, I'm randomly selecting from the group. So the first thing you do is you put them in a group by some category of whatever you're trying to do. And then everyone has an equal opportunity in each group to be selected. That makes sense. But with that being said, each member, it doesn't have an equal opportunity because there could be 100 people here, 50 people here, but maybe I'm pulling 5 from each. So your odds are a little higher here than it is here. But each group has the same amount of people coming out of it. So you can think of this as like your electoral colleges in the government stuff. Every state has a certain amount due to population. They all get a say, but depending on how much is in the group, gets more say. So in a sense, everyone's grouped up by state, and then we randomly selected people out of the state depending on the groups. Yes. Mm-hmm. Yeah. Okay. Well, it depends. Are those people being selected going back into the pot or being taken out of the pot? They're staying in. So they're selected and then they stay in so they can be selected again. Your odds would be higher if you only did it 1 or twice, because you're doing 1 out of 1,000 times 1 over 1,000, and because the odds didn't change. So your odds would be higher for 2 chances than doing it 500. If they got pulled out, it'd be more of an opportunity to do it 500 times, because you would do 1 out of 1,000, 1 out of 999, 1 out of 998, and so on to a 1/2 of a chance. So your math is actually getting slightly bigger because you're having less and less in your population. All right, we'll continue this discussion tomorrow, but we almost just about finished it.